Hey, Zadar. I'm so excited to be here today to speak to you about a very interesting performance topic, blazing fast navigation using speculation rules. But I will start with a quick challenge. Maybe at some point you had one of these phones, the small one with maybe $300 or something, which is running Android. And also you might have the iPhone, the latest one, maybe 17, that was last week, and you are running both of them maybe on Chrome. If you are running both of them on any Chrome version from 109 plus, and you decide to open Google search it for something, and you were lucky and clicked on the first link, this will respond differently for both of them. Who thinks that the iPhone obviously would be the best option? Just show of hand. I have a couple of people. That's obvious, right? It's better hardware and better memory and everything. But I'm going to disappoint you and tell you that this phone will work better than the iPhone, the latest one. That's due to two things. The first one is that Google has applied something called speculation rules for a long time before exposing it to public people to use. That's our topic for today, that you can use today. And the second thing, there is something called browser monopoly, that Apple doesn't allow any engine to run on iOS except the WebKit. So this means that any browser that is running on iOS is actually a Safari, but running with a different skin. So this is not actually Chrome, despite both of them looks like Chrome, but the engine is running on WebKit. And unfortunately, speculation rules is actually working only with Chromium-based browsers for the time being. Allow me to introduce myself real quick. My name is Medhat Dawoud. I'm a senior software engineer working for Miro and a Google Web expert in web performance. If you like or interested in this kind of topic of performance, you'll find more if you follow me on Twitter or check out my blog. Let's move on. I'm going to just step back a little bit and speak about very primitive stuff, about how the web is being loaded for the first time. If you have like an HTML page, just a simple one, very briefly, and you request it from the client, Chrome, to the server, you're waiting to this HTML file to be loaded. Afterwards, the browser is rendering them, find out there is some assets, some files needs to be loaded, and then you wait for them to come back. There's a loader indicator happening, all right? And this case, after receiving everything, we start rendering phase, and finally, voila, you have a page, right? And this is very simple and in very brief way. If the user decided to click on something before that, this might take like 3 seconds or something in the base case. If the user decided to click on P1, in this case, you might have guessed correctly, we're going to start this over. So P1 requests waiting time, getting some assets, waiting for them, rendering them, and finally you have the page. This might take slightly less time because of some cache or something is happening in the background. And this is mostly because of network and rendering time. You have this loading indicator. It could be less, but again, we can do better. So how can we do better in this case? I will start with a fun fact. We humans are slow and impatient species. I am going to prove it for you. How we are impatient? Here's a graph showing you that in 1999, people were perceiving 8 seconds for a loading time for a web page as a fast load time. This was good enough, right? Only 7 years later, in 2006, only 4 seconds was perceived as fast. So this means that people are getting impatient, and you would like the page to load faster and faster. Nowadays, it's only 2 seconds, okay? And you are aiming to have it slow, even faster and faster. So this, despite we are very impatient for having page to be loaded so fast, we're also very slow. For those of you who might be driving, you know something called stopping distance. And this is a combination of two things. There's a reaction distance, and there's a braking distance. Reaction distance is the time it takes you to recognize there is a hazard, and you move your leg and apply the brakes, right? This is considered in the traffic in general to be about 1 second, right? This on hazard, there is something that is going to happen. What about clicking? Time to click. Time to click might be, without any hazard, it takes between 1 to 2 seconds. Can you imagine that? We are so slow. We are just moving the cursor on a link and wait for 1 or 2 seconds and then click. And sometimes we only click, but we don't get the key up or the mouse up. And I learned something about your culture called pomalo. Am I pronouncing it correctly? And this means that you will take everything easy, meaning that these 2 seconds might be raised to 4, 5 seconds as well, right? Just take it easy. And this way, we can make use of this slowness of the people, which I like this culture, by the way. You're not Italians, right? So moving on, you can see that most screens are 50 frames per second. 1 second means we are painting 60 frames, right? Which means 1 frame will be around 16 milliseconds, right? That's why, if you open your performance tab in the main thread, you will find that some of your tasks are being marked as long tasks, because these long tasks takes more than 50 milliseconds. Why we are considering them long tasks? Because they are blocking the main thread, which means that we are dropping more than 3 frames from the user. If there is an animation or anything, the user will notice that there is some glitch or something happening here. This means that you need to do some enhancements. So humans think in seconds, which is slow from the performance point of view. And performance is being measured in milliseconds, which is so fast from a human point of view, right? So I think this combination can help us in doing something that satisfies the humans being impatient and slow at the same time and makes performance so happy. We are aiming here too high. We need to treat the web page as if you are holding a book in your hand and you are just flicking it. Imagine that you are holding a book and it is loading gradually like that. Would be fancy, right? Can you recognize this from where? Yeah, Harry Potter, right? So this would be fancy. You just flick it and wait for it to be loaded. But what if during this loading time this happened? Would you be happy? I don't think so. Or this happened, ink not found. You wouldn't be happy. So what we are going to do is all the way around. We're getting the experience of a hard copy book to the web. So you are just navigating to a new page, and this page is already there. Here comes the speculation rules APIs. That's a relatively new API introduced by Chromium. Chrome specially implemented the first one. And this helps you to pre-render pages in advance and fills in instant navigation. Page loading can have several cases. First one can be loading from the server for the first time, or loading from a cache, right? If it loads from a cache, it can be a cache on the server or a cache at the client. But if it's loaded from the server for the first time, this means that it can be a landing page or it can be a navigation page, right? So for the landing page, that's a different way of optimizing. You have to check everything, all the assets and all the calls that you are making, and you do different way of optimization. Today, we are not caring about that. We care more about the navigation. Here, where the speculation rules play a big role. And if you can imagine this one, if you are loading an HTML file, and you have some links, you make a navigation event, and then another navigation event, and another navigation event. Every time you are going through, the example that I gave to you with all these round trips going to the server and coming back, what we're aiming here with speculation rules, not really to optimize how the HTML file is working, the index HTML file, but we need to optimize these navigation events as it goes. So what we think we can do is to make the loading time for each navigation event way faster than it is right now. Actually, what we're doing is we are anticipating and speculating what the user is going to click ahead of time and load it, so the user only see one part of the loading time, not the entire time. Same for the page 2 and same for page 3. And with the right configuration that we are going to learn today with speculation rules, we can even aim for that. It can be in instant. Just click on one page, and you just found it, as if it was living in the client for a long time. You remember this example from the beginning, right? But now, since we are going to apply this speculation rules script, during the parsing, we find out that there is inline script for speculation telling the browser that these 2 pages, P1 and P2, are going to be clicked, most probably. So please, when you found them, load them ahead of time and put them in a cache. What's happening here is that actually both of them are being loaded, and all these round trips are happening. But they happen only in the background in hidden tabs. And when the user decides to click on P1, it's not going to do all these round trips or even wait for any time. It will just move this cursor from being a hidden tab to the actual tab in the main thread. And this is insane. You will find that you just feel that this is living for a long time at the client. So let's have a look into speculation rules. How can we write speculation rules? It's so simple. It's actually a JSON-like rule that you can add as a normal inline script that you have. It has three things. First one is action. Can be prefetch or pre-render. Prefetch is only loading the HTML, parse it, and just wait for the next step to load these assets and go on and render. And pre-render is the full page. It's being loaded in a hidden tab. Another thing is target. With target, you will decide yourself what kind of link that you would like to load ahead of time. So you can change that from a URL, regular expression, from a selector, anything that you think that this link is the one that you are targeting. And sometimes this can go wrong. And with debugging, you can just exclude some kind of regular expression or something. And this third one is interesting one, is eagerness. With eagerness, we have three types. We have immediate, we have conservative, and we have moderate. So let's have another look or closer look to this eagerness. If you set up something with the eagerness of conservative, this means that if the user decided to click on a link, and on mouse down, you can start ahead of time the loading of this page. So how this is different from click? You can guess, right? Clicking is only happening on mouse up. Actually, it's not happening in mouse down. So we can make use of the slowness of the user by only mouse down before the mouse up, because they are too slow. We agreed on that. We can just give this head start of 1 to 200 milliseconds until the user just mouse up. What about this prefetch pre-render numbers? We have only two prefetch or two pre-render, two links that we can cache ahead of time. And if you just hover over or start clicking on a third link, the first one will be discarded automatically. How long are we keeping this cache? It's only 5 minutes on this browser, just to give you a head start. So what if we go with eagerness moderate? Moderate is more interesting, because if you hover over in any link for 200 milliseconds, we can start ahead of time this loading mechanism, all right? It's only 2 links as well, first in, first out, for both of them, but 400 millisecond head start, because there is high probability when you hover over a link that you are going to click. But it's not that accurate comparing to the previous one, right? The previous one is actually clicking, but this one is only hovering. What if the user is just hovering over the whole page, and you keep loading or pre-rendering or prefetching? Might not be very accurate, but it gives you a better head start. And the third one, and most powerful one, is called immediate. And this immediate one is just searching for any match that matches your target that you set in the speculation rules and load it immediately, either prefetch or pre-render. This means that you just set a target, it scans the whole page for links that matches your target, and there you go. It will be rendered, and when you click, it will be loaded immediately. There is a small problem that we're going to discuss later on in that, because you are going to utilize a lot of the user resources like bandwidth and memory, sometimes uselessly, because you are finding every link and just load, and doesn't mean that the user is going to click on it. This means that this is the least accurate one, right? And in our journey to find out which one is the optimal one to use for this eagerness, it's hard, because if we choose conservative, this is the highest accuracy because the user is already mouse down, but it's very small head start, only 200 milliseconds. Moderate is something in between, 400 milliseconds. However, it's less accurate because it's just hovering over, might not click in the end. And immediate is loading it immediately, very good head start, but some waste of resources because it doesn't mean that they are going to click anyway. The optimal will be here, is to have a better head start, and at the same time, highest accuracy. And this is hard to achieve, to be honest. But we can aim for something just to help out with that. Our aim here is to have prefetch because it's less resources consuming, to have the same target for prefetch and pre-render. The prefetch one, we can set it to be moderate. This means that if you hover over a link for 200 milliseconds, we're going to give you this head start. And if you start clicking, let's pre-render it. So in this case, you are getting the best of both worlds. And in this case, can be 500, 600 millisecond head start. This can be like an optimization for this mechanism, not to have one. But if you can see, both of them are having the same target. So you can just head for the same link. To measure if the speculation rules is helping or not, we're going to depend on some metric. Luckily enough that Google has introduced Core Web Vitals in 2020, and LCP is a good metric that you can use. And if you are not familiar with LCP, it's the largest contentful bint. It's the biggest item that loads in the current viewport. This means that, all right, the user can see something meaningful and helpful in this page. From here, let me show you a demo for how speculation rules can change your navigation. Well, this is an example created by the Chromium team. It has quite a lot of links. And if you can see here in Application tab in your Dev tool, if you open Chrome, you will find this immediately. It's no plugin or something. And you'll find in the background services something called speculative loads. If you click on rules, you'll find that there is a rule happening in this page, and it has 22 links matching this target. Click here, you will find this rule. This rule is just a script in your HTML, right? And it does have a matching of all the links except a specific link. As you can see, the syntax is very simple here. If we click here on these links that are targeted, you will find all of them status is not triggered. However, if we decided to trigger any of them, for example, the first one here is called melon. If we hover over melon, you can see this has changed to be ready, right? This means that this has been loaded in the background. How can I make sure that this is really loaded in the background? You'll find something appear here as well. If you click here, you'll find that this hidden tab has its own div tool. If you switch it to it, this is actually the melon page. But this is happening in the background. It's not the main thread. If you switch back to the main thread, this is the main page. But this is the one that has been loaded in the background. If you open console, I am melon. OK, I'm not staging that. But let's look into it in action. If you open speculation once again, this is not speculated because it's a melon. If I go back to the page that has the speculation rules, this is speculated. If you click on melon now, OK, you wouldn't notice that this is slow or fast because this is actually around 50 milliseconds. But if I hard reload an empty cache, which is treating it now as a landing page, you will find that the LCP jumped to 680 milliseconds, like half a second or something, slightly more than half a second, right? This might be not too big because LCP is considered good from 2.5 seconds, but the lower, the better. If we just reload the page anytime, it can get less or high, depending on the cache or the response. But if we go back and open the application and trigger this again and see that it is ready here, and click on it, it's 62 milliseconds. This is a huge improvement, almost an instant navigation between both of them. So if we go for any page just immediately without waiting, you can see we don't wait for 200 milliseconds, the rule that we put, because we need to load it after the 200 milliseconds. This loads immediately. But if we go back and hover over Apple, OK, and it looks like ready in the div tool, I click, this is 65. It's like 90% in improvements without doing any improvements in performance or assets or do all the hassle. It's just going on and have a rule to enhance the navigation. If we have two links like this in the same page, you'll find that this Apple is Apple again. We are not going to load it again. If you put the rule once and it is matching any number of links, the same link in the page, it will be just one, always. If I go back and hover over another one, you will find that there is a failure for the first one. As you remember, first in, first out. OK, so we have now just pushed the first one out, and we load a new one. Same for any one in the list. All right, this might have been staged, right? I'm going to go with a challenge here to open PPC. OK, and this is just, I'm giving you an example that you can try in your own project today. If we open this for any piece of news, all right? This is performance tab to measure the LCP. If I decide to click here, this takes like 500 milliseconds, right? And this page, or this website in general, doesn't have any speculations. But if I go to console and I have a script created for it, I am searching for any link that starts with /news/articles. How I know that? Because if we go here to this, to this link, we will find that this hyperlink is /news/articles. You can do that easily. If I go to console and run this script, this means that it will have now speculation rules. As you can see, all the links now are listed in our DevTools. If I hover over this one, it's ready, as you can see on the right-hand side. It was 600 milliseconds, right? Something. If I click here now and open performance, it's 100 milliseconds. 100 milliseconds. And this is a huge enhancement. As I mentioned, performance is being measured in milliseconds, and every millisecond matters, all right? Imagine if you have even a weaker LCP in your website, like 2-3 seconds or something, out of the box, without doing anything. You can do that, and I encourage you to do it, actually, to enhance LCP. But without doing anything, you can just get this head start out of the box with only having this speculation rule set up, all right? Let's go back to the presentation. So the main takeaway here is that your DevTools is already enabled for you to debug and find out your speculation rules and speculated pages. And you can debug it as well in a separate DevTools, as I showed to you from the top. And unfortunately, I'm going to disappoint you a little bit that this is not fully supported yet. This is not a baseline. However, despite it's only Chromium-based browsers, and other browsers are only giving some signals that they are going to introduce it a little bit later, you can introduce it as a progressive enhancement. So you are not shipping this script everywhere. You can just, it doesn't do anything, actually, if you ship it everywhere. But if you would like to ship it only for the browsers that are supporting it, you can just wrap this script inside a condition. But not only that. Imagine that this is dynamically added to your page. So if you do have any kind of analytics or behavior monitoring for the user, and you know exactly the funnel, what the user is going to click next, you can just add this information to this speculation rules. So you know your funnel, if you have an e-commerce or anything that people are clicking on this, then that, then this. You don't have to match all the links. Just match the links that you know that this user is going to do it. You can do it very personalized. And it's up to you. It's dynamic, all right? So you might think, can I pre-render all links so I can make the life is so pink for everyone? YOLO, right? Short answer, no. No, you could not for everything, and no, you should not. Why you cannot do that? Because Google prevents you in favor for the user. If the user decided to enable safe data on their devices, they are not going to speculate. Because actually, speculation is running some processes in the background, and this will use some data and bandwidth from the user. If they decide to disable that, so the Chrome is not going to just do it. Chrome also prevents any tab in the background open. It's not going to speculate any links, that is even if immediate. If the user enable energy saver, also this is going to be ignored. If the user have an ad blocker and this ad blocker is preventing the pre-render for pages, also Google is going to respect that. If you have memory constraints, of course, our browser does have a memory, and it's a limited memory, right? And this memory, if it's full, I believe some of you is having this Chrome browser with this pyramid tabs, like 200 tabs open, right? How many of you is doing that? I'm guilty doing that as well. But now, you know, maybe with different browsers with horizontal tabs, I am avoiding doing that with different folders. So if you have this memory full, in this case, memory, the Chrome is going to respect that. They are not going to utilize more memory. Say, OK, no enough memory to pre-render this page. So we're going to ignore these speculation rules. And finally, if you have cross-origin iframes, also this Chrome is going to ignore this case as well. So let's move for the things that you should not. It's not preferable to do that. First of all, sign out URLs, obviously, right? You're not going to speculate the user, sign out, and sign them out. No, don't do that. Sign in, that requires maybe two-factor authentication or something, or send an SMS. Don't spam the user. Language switcher, one page in German, one page in English. Don't do that. URLs that increments some allowance for the user. If you are speculating that, so actually you're helping the user in somehow, but it's not fair, right? If you are speculating that. Add to cart. Don't buy things for the user. So don't speculate these URLs. No. And finally, if any script, and this is the most common one, any script that you are running or URL that is calling tracking events or something, don't speculate that, because this will mess with your analytics data, and you don't want to do that. This is a very common mistake that people are doing with speculation rules. And given the fact that it's very dynamic to write speculation rules and exclude some links, you can use them to exclude these kind of links. How can I find out if one of the links is just matching my target mistakenly? You will find one of these two headers. Okay, so it has sig purpose, prefetch or prefetch pre-render. This means that this script or this link or this page has been called in a pre-render, in the background. If you find out that, just go ahead, adjust your target, and come back again. So any downsides for speculation rules? Till now, it feels like, OK, this is a silver bullet. Everything is going very well. No, it does have some downsides. I don't call it downsides, to be honest, but it's downsides for some people. First of all, it's not supported everywhere. So you can say, all right, I'm going to enable speculation rules, and every user on Earth is going to use it. Yes, Chromium-based browsers are being used with like 70-something% of the population, which means the major user base are going to benefit from that. But still, it's not supported everywhere. This is a downside. Another thing, privacy and tracking. Just as I just explained, you might mess with the tracking and analytics using these speculation rules if you didn't write it well, if you didn't target well these links. Third, who is here is using single-page apps? Creating new single-page apps. That's the right question. If you are starting a new project, would you use single-page apps? I don't think so. However, this is not supported yet in single-page apps. There is a plan to have it supported in single-page apps, but I don't think any new or modern project is now depending on single-page apps, except for the ones that you are still supporting but built in the past. So no support for single-page apps, unfortunately. So if you have a single-page app and try this and it doesn't work, you know why. And finally, and most importantly, is a problem that this is utilizing some memory and bandwidth from the client. And sometimes this is not really important, especially if you set up this immediate eagerness. And this means that you are loading like 10 pages ahead of time, and the user barely might click on one page. This is bad. For that, especially, I'm giving you an extra bonus step. Enable something called dictionary compression. Have you heard of it? This is important to try on the server. If you enable it, this will give you something like that. If you have two versions of your application or of your maybe library, let's think about it, 2 pages. Page 1, which is version 1, okay, and page 2. If you think about page 2 and send to the server, use page 1 as a dictionary for page 2, and instead of sending the whole file again, and I don't think that any page on a single website does have a completely different context and assets than the previous one. Using the dictionary compression, you will send only the changed part of this page. This is only something that you can enable on the server, and it will work out of the box. Here's an example of how it works, or the numbers that comes with it. It's actually with Protly 11, which is good compression, but with Protly 11 plus the dictionary, it's too different. It's 85% enhancement with YouTube desktop app, and it does have a 96% enhancement with Vercel. This is insane. If you enable it, this will resolve a little bit this concern about having a big bandwidth usage or data usage or memory. So speculation rules API comes hand in hand with dictionary compression. If you enable them or use them together, there you go. You can just pre-render a lot of pages without any concern about utilizing a lot of the client or the bandwidth. And now it's your turn, all right? First, you need to try out the speculation rules API using the script I just used. Just write it in your console before trying it or implementing it. Just do it and show it to your manager and just get some bonus or something, or maybe a raise. Just remember me. And next, try to enable compression dictionary, and this will help you anyway, regardless of speculation rules or not. If you try it, this will enhance a lot in the usage of the bandwidth. And you need to keep optimizing, actually, for this, the first load. If you have this in a landing page, as I have seen, anything that I enhanced it with navigation, if you hardly reload it, it will be just a landing page, all right? Yes. And finally, an extra tip, if you combine the speculation rules with cross-document transition, this will help a lot. In this small transition, the user will just perceive it as it's so fast, even if you get only 200 milliseconds in that. And with that, Hivala, thank you very much for listening up. You'll find a lot of resources here for that to read more, and feel free to reach out to me either on Twitter or on my blog, or even come to me. I will be here after shift or maybe tomorrow. Thank you very much.